So let's look at limits and continuity in higher dimensions. This one's a little bit more interesting of a topic, I think, because it's more what you're used to in calculus. You actually get to look at some limits now. The limits. So first we're just going to look at different limits. Mainly, that's what I'm mainly evaluating here is limits, and then we'll go on to continuity a little. Telling when it's continuous and when it's not. So xy approaches 0, 0. Both coordinates are going to 0 and 0 here. 3x squared minus y squared plus 5 divided by x squared plus y squared plus 2. This is just a plug-in type problem though. Because these limits, we're just evaluating these limits, and sometimes they can be just evaluated when you're given the points. And you get 5 halves, and it's quite, quick like that. Number 5, it's, approaching 0 and pi fourths. Secant x tangent y, and we just plug in 0 and pi fourths. And secant of 0 is 1. That's because it's 1 divided by, you could think of 1 divided by cosine of 0, and cosine of 0 is 1. So 1 divided by 1 is 1. And tangent pi fourths, similar, it's sine over cosine of those same values. Sine of pi fourths is square root of 2 over 2. Cosine of pi fourths is square root of 2 over 2. So division by the same two exact numbers would be 1. So it's 1 times 1, and that's equal to 1. Here's one where x and y approach 0, 0. The limit is e to the y sine x divided by x. Now we have to actually use a little property. The limit of, theta approaches 0 of sine. This should be theta and theta. But point is, you can say x approaches 0. Either one, that's a little mistake, but I'm trying to use a general example, I guess. Same thing. Basically, the limit as you approach it of this expression of sine x over x, of x approaches 0, or theta approaches 0, whatever you want to do it, if the variable is sine. So sine of theta or sine of x over x or theta, whichever variable, same variable, point is, it's equal to 1. And we can, this is multiplication, so we can split it up into two limits. Limit of xy approaches 0, 0 of e to the y times limit of xy approaches 0, 0 of sine x, x, 5x. And that's e to the 0, you evaluate it as 0, times, and this can be simplified down to just x, because that's the only variable present in that. X approaches 0 of sine x, x, which is equal to 1 times 1, because e to the 0 is 1, and that's 1, so it's equal to 1 again, like the first problem. Okay, time for a little bit more tricky, I think. Now we have to use a trick where we simplify the expression before we can evaluate it. So x squared minus 2xy plus y squared divided by x minus y. Xy approaches 1, 1. So if these basically are approaching each other, 1 minus 1 will eventually equal 0, and that can't exist in the denominator. So we have to eliminate it. And we do this by factoring this into two binomials. I think that's correct. X minus y and it's x minus y squared, because I think it's a difference of squares or whatever, I think technically. Regardless, if you figure it out, it's x minus y times x minus y divided by x minus y. So it just becomes x minus y. And x minus y is 1 minus 1. So it's equal to 0. This one's a little bit more complicated. It's approaching 0, 0, and square root of is x minus square root of y is in the denominator. So that means it would be 0 minus 0, so you have 0 in the denominator. Okay, we have to get rid of that. We have to eliminate that stuff in the denominator. So this is equal to... in the end, I skipped the works down here, but this basically we're going to end up with that at the end. I basically showed this so I don't have to repeat writing out that limit, because these limits are kind of annoying to repeat, especially when you have multiple variables. It gets really complicated. It gets a lot of space, a lot of small spacing. So we're simplifying this expression. I copied down just the expression itself, but how we could, in any type of algebraic expression, simplify it. So square root of x squared minus square root of y squared plus, so I basically converted x minus y, like x and y themselves, into square root of them, but squared. it's the same expression because the square root of something that is squared will be the number inside. So x is equal to square root of x squared, and y is equal to square root of y squared. And I also distributed out a 2 from square root of x, square root of x minus 2 square root of y to make it. And there'll be a reason for that in a step. So we turn this into 2, we basically factor it out, do factoring. It's basically a difference of perfect squares, I guess you could say. So using the technique. And it's square root of x minus square root of y times square root of x plus square root of y is what you get from this first part. The denominator hasn't changed yet. We're trying to eliminate the denominator somehow. And then we still have that distributed out. The point is that square root of x minus square root of y and square root of x minus square root of y are both in both expressions, so you distribute that out of the whole thing and get square root of x plus square root of y plus 2 from this. And you cancel out the denominator and you get square root of x plus square root of y plus 2. That's what's up here. That's where we evaluate the limit at. So it's square root of 0 plus square root of 0 plus 2, which is equal to 2. So the whole limit's just equal to 2. So this one, another evaluation. This one's not that bad but you have to really recall this trick. A cubed plus b cubed and a cubed minus b cubed can be factored, these expressions. First one, a plus b times a squared minus ab plus b squared. Another one is a minus b times a squared plus ab plus b squared. So the sign stays the same, you can remember it. And this one's the same as that expression. So this one's always positive, the last one. First one is the same as the sum or difference, it's the same. Then this one is the opposite. So plus minus, plus minus, plus plus. So it stays, I think SOAP is an acronym, you could say. So it's same sign, opposite sign, and then always positive sign. That's how you factor this, and you have to use that because we have to eliminate. We have x cubed plus y cubed divided by x plus y. So down here again, like last time, is equal to x plus y times x squared minus xy plus y squared, basically divided by x plus y. I'm applying it very quick, and it becomes just x squared minus xy plus y squared. So that's where we evaluate the limit as it approaches 1, 1. Oh no, 1, negative 1, yeah. So it's 1 squared minus negative 1 plus negative 1 squared is what it implies down to and plugged in. And it becomes 1 plus 1 plus 1 equals 3. See? Okay. So finally we just have to look at some continuity problems where we just tell if it's continuous. We do it. Yeah. Oh wait, no, we have a couple more limits. So these ones we don't have to do anything, we just have to plug in pretty much. No cancellation for these last couple. So yeah, p is used commonly for 3 variables. So sine squared x plus cosine squared y plus secant squared z, pi, and 0 we plug in respectively. So sine squared pi plus cosine squared pi plus secant squared 0. So this is just sine, cosine, and secant values squared. So 0, negative 1, and 1, because sine of pi is 0, cosine of pi is negative 1, and secant of 0 is, as I said before, it's 1 divided by 1, which is 1. You just square each of these values, so you get 0 plus 1 equals 2. That's what the answer is. Then this one is z e to the negative 2y cosine 2x, and we have to evaluate at pi 0 is 3. So that's 3 times e to the negative 2 times 0 times cosine of 2 pi. So that's 3 times e to the 0 times cosine 2 pi. It's equal to 3 times 1, which equals 3. Because e to the 0 is 1, and cosine of 2 pi is 1, yeah. Yeah, cosine of 0 is 1, cosine of pi is -1, and cosine of 2 pi is 1, and it goes on. As you know, the cyclical nature of it. So now we just do a couple continuity problems. That's it for this section. So f of xy equals sine of x plus y is continuous for all x and y. I'm just going to state what these functions are continuous for and show the work accompanying it. So this one, I think that's pretty obvious. Sine of x plus y will be always continuous because the sine function accepts any input value pretty much. You know, it only has a small range, a narrow range of values it can take on between 1 and -1. But its domain is all numbers pretty much, as we can tell. At the very least, real numbers, all real numbers. Now, another type is f of xy equals ln of x squared plus y squared. So ln of x squared plus y squared. This is not going to be always continuous. Natural log functions are not always continuous as a general rule. Because as you know, you can't take the log of a negative number or 0. Pretty much is the general rule. That's why you find out exactly, you know, it's except 0, 0 in this case. Because naturally there's basically an ln theta, the natural log function basically of any value. You have to have theta greater than 0 to be defined. X squared and y squared are always going to be greater than 0. Or greater than or equal to 0. Should be the proper thing, but regardless. Point is that these are always positive numbers. So only 0 squared plus 0 squared equals 0 would imply 0, 0 is not continuous. That's pretty much what's going on, is that that's the only point. 1.00 would be where it would not be. Because any negative values or positive values that are not, you know, positive values except for 0. Like -2, if you're squaring -2, it's 4. And 2 squared is 4. So really you only have 0 and 0. Only times where you get 0 as the whole. X squared plus y squared equals 0 only when both are 0. Both x and y are 0. Couple more. G of xy equals sine of 1 divided by xy. This is continuous for all xy except where x equals 0 or y equals 0. Either one of them, pretty obvious. 1 divided by 0 occurring is not good. You avoid it, or else it'll be non-continuous at that point. So that exists for whenever x or y, because it's multiplication of them. So anything multiplied by 0 is 0. G of xy equals x plus y divided by 2 plus cosine x is continuous for all xy. And to demonstrate this, 2 plus cosine x never equals 0. That expression will never. Because -1 less than cosine x less than 1, that's what cosine x can equal. That's the range. So 2 plus cosine x, you add 2 to each side. You add 2 to that, to cosine x, and you add 2 to -1 and 2 to 1. So it could assume any value. The denominator could be 1 and 3, anywhere between 1 and 3. And that should be less than, I keep on forgetting these equal signs. Point is, though, you know, it has to be either 1, it can be greater than or equal to 1 or less than or equal to 3. But it can't be anything beyond those parameters. A few more. F of x, y, z equals x squared plus y squared minus 2z cubed is continuous for all x, y, z. It's simple. There's nothing that can make it undefined or anything else. Pretty much making a function being undefined is like the number one cause of non-continuity if there's a point where it is not. I think in general. That's what we've been looking for, at least to be able to tell right away. So now we have the square root of x squared plus y squared minus 1. For some reason it's given in x, y, z when it's just x and y as far as I can tell. It's continuous for all x, y, z except where x squared plus y squared is less than or equal to 1. You can say that it's continuous for all x, y, z satisfying x squared plus y squared greater than 1. Yeah, basically x squared plus y squared have to be greater than 1. Because x squared plus y squared minus 1 is a square. It's a square root. So this whole thing has to be, you can't take the square root of a negative number. Yeah. No, you can't. Even though greater than, it should be greater than, whatever. Inequalities aside, being a little bit off. Point is, I think you get the point. So this can be 0. You can have a square root of 0. The square root of 0 is 0. It's defined. So if x squared plus y squared does equal 1, then 1 minus 1 is 0, and it's fine. So x squared plus y squared has to be greater than or equal to 1. Little typo there, but whatever, or weird mistake. H of x, y, z equals natural log of z minus x squared minus y squared minus 1, and I'm just ending with this one. Because it's continuous for all x, y, z satisfying z greater than x squared plus y squared plus 1. Reason is that, you have to have your natural log has to be greater than 0. So you just add on you add all these terms on the right side where it's greater than 0, and you get z greater than x squared plus y squared plus 1. That's the way of writing out this thing. So yeah, that's basically all you have to do.